Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
So welcome to this episode of GOTO Unscripted. We are live at GOTO Aarhus, which is very exciting. It's my first time in Denmark and indeed my first time at GOTO, so that's been lovely. I'm Charles Humble. I am currently Container Solutions Chief Editor, and I'm joined by Holly Cummins from Red Hat, where she is a Senior Principal Software Engineer in the Quarkus team. Have I got that right?
More or less, yeah.
It's a very long job title.
Yeah.
So that's good. So we met up last night over dinner, at the conference dinner briefly, where the brilliant Sam Aaron was doing his live coding DJing thing, which was phenomenal. And in the middle of that, we were talking on the same table but to different people, and we both basically had exactly the same cloud native story, which was so funny, which was essentially this thing of, we're going to microservices because we want to move faster, but then we have a change control board who meets like twice a year, and possibly microservices are not the answer to your problem. And I found myself thinking as we were chatting off camera that there is this thing about sort of shoehorning architectures into cultures where they don't belong. And I thought with some of your background from your consulting days at IBM Garage, that might be just an interesting sort of thread to pull on a little bit. So do you have sort of thoughts on that?
Yeah, I think there's sort of two anti-patterns that we see. One is shoehorning the architecture into the place where it just doesn't fit. It's solving the wrong problem. The other thing I see a lot is maybe the architecture is actually the right architecture, but we haven't looked enough at the surrounding context and tried to figure out, well, what's actually necessary for this to be successful. So with microservices, for example, what happens a lot is, first of all, a lot of organizations don't actually ask, what problem am I trying to solve by going to microservices? They assume that because everybody else is going to microservices, it must be the right thing for them. Yeah. But then once we go one step further than that, then it's, okay, I want to go to microservices because I'd like to move faster, which is a reasonable goal, and that's definitely something that the style is suited to. And then it's, okay, so I've switched to microservices, so I have made my application distributed, and now I'm going to go faster. Well, no, making your application distributed doesn't make it go faster. What you have to then look at is, well, how often do I release? What's the process for a release? Also, how do I test these things? And if I have to test everything in a big homogeneous monolith because otherwise I don't have the confidence, then actually the fact that there's distributed communication doesn't matter because it is deployed as a monolith. So then it's just, that slightly bigger picture of what are the conditions for success? Have I looked outside the code to make sure that those conditions for success are there?
Yes, yeah. I mean, there's a couple of things there. So there's the classic getting your sort of service boundaries right so you can deploy things independently, which is actually incredibly hard a lot of the time. And I have certainly worked on systems, and I wouldn't be surprised if you have as well, where it's like, we've got a bunch of microservices, but this lot all have to be updated at the same time, because otherwise the whole thing breaks, right?
Yeah.
And all you've done is make everything more complicated.
Exactly.
But then also I think there's the sort of cultural aspects of, it's a bit like, there was that time when everyone was doing a sort of agile transformation, and I think now we hear agile transformation and kind of shiver a little bit inside. Right?
Yeah, and yet they're still going on.
And it's still happening. Yeah, no, absolutely. But it's that, because you're trying to, in order for this to be effective, you need to change the way people work. So, if you want to move faster, then that require. There are various reasons why people go this route, but that's certainly one of the reasons that people go this route, and that requires you to work in smaller chunks, have less work in progress, all the stuff that we kind of know. But in large enterprises, in my experience, actually making that change stick is incredibly difficult. And I think that's kind of interesting as well.
I think a lot of it is about trust, and there's two sides to the trust. One is the cultural side of, is there a culture of fear, or do people have the autonomy, or does everything have to go through a central silo of regulation and control? And part of that is about in regulated industries, and that ends up being more necessary, but not entirely necessary. But then the other part of it is the technical trust, because often the reason organizations are unwilling to deploy their microservices individually is because there's, it's not a paranoia, there is quite a high likelihood that if deployed individually, they would break. So it makes sense to have a QE phase where everything is tested in a batch. But the thing is that both are resolvable, and so there's things like contract testing and fuzz testing and matrix testing and that kind of thing to some extent can give an organization the confidence to be able to deploy without having to do the testing of everything in a big batch, which gives you such a win for the speed and really brings you much closer to those goals that you were probably trying to do by going to microservices.
Yes. I've also seen the thing of developers or senior developers or architects being kind of attached to particular sort of styles of architecture that maybe don't quite work in the distributed world. The classic used to be, you had a load of microservices and then one central database. I think we've probably got away from that more or less, but you do see things like, I really want transactions, but distributed transaction coordination is quite hard, and you get into that, I need sort of compensating transactions, or sort of saga pattern stuff. And again, I wonder if there's a sort of connection there in the same way that changing the way people work at a cultural level to changing the way software architects kind of think about what they're doing. I
think so, and I think it's really easy to sort of judge as well. And to go, oh, look, you're doing things the way that you used to do them 5 or 10 years ago, silly you. But there's such a lot of cognitive load, and there's now, there's sort of all these interesting charts that show how our cognitive load as developers has increased so much compared to where it used to be. And so then that does mean that realistically it's hard to keep up. And, it's not because we're stupid, it's just because there's a lot coming at us, and sometimes you have to say, okay, new style of transactions, that's just a bit too much for me to digest at the moment. I will stick with what I know because that's what humans are good at. Right,
yes. I think something else I was sort of reflecting on quite a lot. I mean, we started in the industry similar time. I think I was a little before you, but that sort of point where everything was sort of proprietary and, everything was closed source and knowledge sharing was a real problem. And the sort of second part of my career, I spent a lot of time just thinking about how we as an industry get better at sharing knowledge and passing on what we know. But I was interested to get your reflections on that, because obviously you've kind of come through that same sort of transformation of a sort in our own industry, I guess.
I just think it's so incredibly positive, and it feels almost utopian actually, the sort of shift from proprietary to open source, and it just seems to benefit everybody, which is really nice. It's nice when you get something where it's not, there's one set of winners and there's one set of losers. All of us are benefiting. So you have the sort of the enterprises, like I work for Red Hat now, they've made a very successful business on 100% open source. But then for me as an individual developer as well, it's just so delightful that if I need something, I can go and I can access it and it's open source. And if I find it doesn't work, I can fix it because it's open source. And it's hard to imagine even now going back to the days where everything was just so closed and you didn't know what was going on under the covers, and sometimes there would be quite a simple bug, but you couldn't fix it because you just didn't have that access.
Yeah, it's a huge change. And of course, we also came up through the sort of very early stages of Java. So if I remember rightly, you were on the WebSphere team at IBM.
I was, yeah.
And then on WebSphere Liberty, I think it was called, the sort of,
exactly.
the kind of, the sort of sequel, as it were, to the original WebSphere product. And again, I think it's quite interesting to think about that as well, because Java has obviously been around a very, very long time. It's still a very widely used language. But the world that it was kind of conceived for, from an architectural or from a software point of view, is radically different from the world we find ourselves in now. So, WebSphere was designed to, it was slow to start, but then it would sit and run pretty much forever if you left it alone.
Exactly, forever. And the scale of forever, I think, is one that sort of doesn't really even make sense to us now, that it would go and it would not be restarted for 6 months, a year, that kind of thing. And so it was designed to be incredibly dynamic, because you were basically changing the engine as the plane was running. And then when we went to WebSphere Liberty, we made it even more dynamic, in fact, so you could, you could change every single part of it as it was running. There was an interesting thing with WebSphere Liberty, actually, because obviously originally WebSphere wasn't conceived for the cloud, because the cloud didn't exist when it was being written. And with WebSphere Liberty, the problem that they started out trying to solve was, how do we keep the same programming model as people are used to with WebSphere, so that 100% compatibility, really, but make it a friendlier experience for developers, because developers do not start their application server and leave it running for 6 months. That's just not how we work. And so we made it so that it was much quicker and lighter to start, and that kind of thing. And that was just at around the dawn of the cloud. And then we realized that catering for those developer requirements actually made it incredibly well suited for the cloud, which was something that, it was just a happy coincidence. And I think if you said, did you know that developers are exactly like clouds, it would be a nonsensical statement. But the requirements end up being similar. And we've sort of seen it a little bit, that same thing, because now I work on the Quarkus team, and Quarkus was very much designed ground up to be a cloud native way of running Java. And so with the dynamism that you have in more traditional runtimes, you pay a tax for that. But when you're running in a container, you don't need that dynamism. So it makes no sense to be paying the tax. So things like reflection are expensive at runtime. And so what we've done with Quarkus is we've massively reduced the amount of reflection. We've moved more to be build time optimized, and then that means that at runtime you have a quicker startup, which may or may not be helpful, but you have lower memory requirements, which almost certainly is helpful, because in the cloud memory is money, and you have faster throughput, which is always helpful. But then as sort of a consequence of that then, so it goes in the other direction, because it does more at build time, for a developer, that's not necessarily ideal, because we're building all of the time. So then the question is, okay, so what do we do so that you don't have to do all of that build time optimization for the whole application every time you change a line of code? And so what they've done is they've built a really, really good live reload experience and a really, really good continuous testing experience, so that you have, again, it's that sort of that same combination of a really optimized for the cloud, but also this delightful developer experience. And there's sort of two aspects to the developer experience. One is just the liveness and the hotness. But then there's another, again, I think slightly unintended consequence, which is if you do more at build time, you understand the context in which the application is running much better, which means that a whole bunch of boilerplate that we used to have to write as developers to say, okay, so this is there and this is there, and could you please do that, isn't necessary anymore, because there's a deeper optimization phase at build time. So then it ends up being better for developers, just because they have to write less code as well.
So can you talk about a bit more about sort of how that works? Because as you say, you're doing as I understand it, you're effectively building, you're using the GraalVM, I think, right? So you're doing sort of native images, but I'm presuming you're not doing that when you're doing your normal development work, because that would be too slow, right? So
yeah, a native compilation is about, it seems to take about 3 minutes. I mean, that sort of obviously depends within the application, but that's the sort of order of magnitude.
Yes.
But one of the things about Quarkus, which is interesting actually, is it can run in 2 modes. So it can run as a native application, or it can run on JVM. And native, I think, is getting a lot of the headlines because the startup times are just dazzling. Like I benchmarked it, and it's actually faster than an LED light bulb to start up, which is, it's just flat out incredible. Yeah. And when I first did my native application, and I just started it, and I stopped it, and I started it because it was just so magical.
Yes.
But what we do see, and that's all built on GraalVM.
Yeah.
But what we do see with the native applications, I think the gap will shrink. But with the native applications, the throughput does tend to be lower. So the startup time is just absurdly fast. The memory is quite small. So if you're running in a constrained environment, or if you're doing something like serverless or any kind of scale to zero, or if you want to have kind of a cloud bursting pattern, then it absolutely makes sense. If you're running an application the way you've always run your application, native maybe isn't the best choice, but the optimizations that the Quarkus team did to make it work well on native, it turns out actually are optimizations for Java as well. So if you run on JVM, some of those things like doing more at build time, getting rid of reflection, actually mean it's faster on the JVM as well. So we see, even on the JVM, the resource consumption is about half of what an application that wasn't using Quarkus would be, which is pretty incredible.
Yeah, that's extraordinary, isn't it?
Yeah, I mean, it's just so good. And again, that's sort of across the board. So the throughput is higher, not twice as high, I think. Again, depends what application, but certainly the throughput is significantly higher. Your memory consumption, everything, it means that you can run in a much more economical environment.
Right, yeah. I want to pick that up in a sec, but I'm curious about what the sort of programming model feels like, how you handle things like sort of dependency injection and that sort of stuff. Because again, it's quite a change from, the sort of Java and J2EE, if we're that old, and even sort of early days of Spring. It's quite a shift in terms of the sort of programming model in some ways. Yes
and no. What they've done is they've stuck to the standards. So if you're using microprofile, then your microprofile application, that's the sort of the base programming model for Quarkus. So your microprofile application will work fine. If you're using Hibernate, for example, the Hibernate team virtually sit next to the Quarkus team. So again, there's a really nice integration there. What you can do though is you can do less of it. So things like, just some of the boilerplate that you might have to do with Java EE or with microprofile, there's less of it. And we have some libraries that again build on top of it, just to give you that slightly slicker experience. So for example, we've got a library called Panache, which builds on top of Hibernate, and it means that quite a lot of the things that you do with Hibernate, you end up having to do sort of in every application. Let me have a method that gets everything. And it just auto-creates those methods. So it's quite nice. One of the other things, and again, injection is really core to the programming model, and it's the microprofile injection. And we do it for all sorts of things, and in quite cool and clever ways. So for example, if you're using Hibernate and a database, you can, in your application properties, you can configure where your database lives. But if you don't configure it, because we understand what's in the application, we can look and say, you're using a database, and yet you do not have a database. That will be a problem for you. Let me use test containers to magically spin up a database. Because you're using the injection, you don't need to tell me about test containers. You don't need to say, please, could you use test containers to give me a database? We'll just find those injection points, put the test containers database in there, and then it just magically works. So that's useful for testing, but it's also useful, again, in the dev mode. So it means that you can just start going, and you haven't actually done anything to define a database, and you have a database. You don't want to deploy to production like that, but it gets you a lot of the way.
Right, yeah, that's really interesting. I was just thinking as well, so one of the things I remember reading in the quite early days of the GraalVM stuff was, you can't use reflection, and there were various other things. There were limitations that came along with essentially trying to run a virtual machine language natively, which is hardly surprising.
Yeah.
I haven't really followed how much that's kind of shifted and evolved with time. But in terms of, I'm presuming the big, you mentioned Hibernate, so I'm presuming the big libraries have done work to make themselves more GraalVM compatible. But has that sort of story evolved? Because to be honest, I haven't really followed it. So
it's not my expert area, but the understanding that I have is that a lot, you definitely do need work. So you need to do things like declaring what happens by reflection and that kind of thing. And what we've ended up doing for a lot of it is we've put that extra stuff in Quarkus. So a question came round on one of our internal mailing lists recently to sort of say, I'd like to do a natively compiled application and I want to use these libraries. And could I do it just with straight GraalVM? And the answer was yes, but it will be an awful lot of work and you'll have to chase a lot of bugs. And if you do it with Quarkus, it will just work. So we've sort of, tried to take those extra things that you need to do. Because some of them aren't trivial. Some of them, again, need to be extra things that are done, extra declarations, but some of them are extra steps that happen in the build phase. So that's hard to do without something a bit external and something that has those injection points in the build phase to say, okay, now let me look around and make sure that everything's going to work. And we have seen that, sometimes when frameworks take those libraries and try and put them in GraalVM, it doesn't always work.
Right, yes, yeah. Are there specific kind of sweet spots for Quarkus? Are there specific places right now where you think that's absolutely the right kind of use case? Where would you recommend people pick it up and choose it over one of its competitors or one of the alternatives?
To be honest, almost everywhere. So a lot of the conversation about Quarkus has, because of the native mode, has focused on those serverless applications, that kind of thing, and microservices. But we are seeing it being used as well for the larger monoliths. At some point, if you have a very large monolith, you may end up with some class path contention and conflicting dependencies and that kind of thing if your dependency space becomes too big. And that, so far, is not the sweet spot for Quarkus, because it does have a flat class path. But right. Assuming you're not at that scale of dependency hell, for almost everything else, Quarkus works really well because it's the Java EE programming model, it's the microprofile programming model, but the resource consumption is so much smaller. So everywhere it will be a benefit. The benefit will probably be multiplied for things like microservices. So going back to that discussion that we were having at the beginning about, are we applying these patterns unthinkingly and are they perhaps creating problems? One of the things that we're starting to see now is businesses are coming to us and they're saying, I've switched to microservices and I have my business agility is great, but unfortunately my cloud bill has quadrupled, which I wasn't really hoping for, because when you imagine that for each application there's the cost of the application, and then there's the cost of the framework, and then there's the cost of the infrastructure, so your control plane and your nodes and that kind of thing. And if you have so many more nodes, then that means that your infrastructure tax is going up, and sometimes your memory consumption and that kind of thing is really much higher. And so those organizations, when they switch to Quarkus, are able to then get their cloud bills back to a much more acceptable level.
Right, yes. And I know you've also done some work, I mean, you sort of touched on this already, but you've also done some work looking at effectively the sort of carbon footprint of running Quarkus versus other leading frameworks we could name but probably shouldn't.
Yeah, exactly.
So can you talk a bit about that? How's that kind of, I know that's an area of interest for you, but how's that kind of worked out? What are you seeing? What are you measuring? Because obviously measuring carbon is in itself quite a challenge. Quite a challenge still. I mean, it's something as an industry we need to get better at and we're starting to look at, but it's an interesting, very difficult area in many ways.
Yeah, there's sort of a side conversation there of, as you say, measuring carbon is hard. It really shouldn't be because it's really important. Can we make this easier? So some of my colleagues are looking at that. But when I joined the Quarkus team, we knew it was really light, we knew it was really fast. We thought intuitively that should translate to being greener, but we didn't have any evidence for that. We hadn't done the measurements. And so I did sort of a series of measurements. One was doing it by inference. So if you know what cloud instances you're running on, you can work backwards to an approximate carbon footprint. And that was sort of for real life load over an extended period of time. And the other one was in a more controlled environment where we had instrumentation in the CPU and we could see exactly how much energy was being used and then translate that to carbon. And in both cases, what was really good is when you do a measurement in two different ways, you really hope that the results are kind of consistent. That gives you a sense of confidence. And the results were pretty consistent. In both cases, we saw that the carbon footprint with Quarkus was reduced by a factor of about 2 or 3. So that was really nice. But one of the things that was interesting and surprising to us was when I first got the results back where we compared native and JVM applications. So again, we looked at Quarkus on JVM, Quarkus native, more alternative framework on native and alternative framework on JVM. And because native has such tiny resource usages, you would assume that it has the lowest carbon footprint. And I think certainly there's ways that you can run it in which that is definitely the case. You have it in a highly elastic mode, you scale to 0 when it's not being used, definitely it enables that. But if you just take it as I have steady load and I am running it, the footprint of native, the carbon footprint, is higher than the carbon footprint of running Quarkus on JVM, and the same for other frameworks. And it's because there's a couple of things that contribute to the footprint. One is the memory, where it's much better on native, but the other one is the throughput. So you need, to handle the same load, you need more native instances, and so then that means that overall your carbon footprint ends up being a bit higher. So it's sort of, it's interesting, and it's also, I think, slightly annoying because it was such a counterintuitive result, and that means that when you're reducing carbon, ideally you want it to be that you can just do what seems to be the intuitively right thing and get the right outcome. And here we kind of saw, actually, no, you do need to be a bit more data-driven and evidence-based and actually do the graft to measure it, because otherwise, it's not a disaster. If you're running on Quarkus, either way, you're better off. But if you wanted to maximize the greenness, you would run Quarkus on JVM.
Yeah, which, as you say, it's not what I would have thought either, right? It's sort of
no,
because there's so much of this. If you want to be greener, you like rewrite everything in Rust or something. And there have been some studies done on the relative carbon footprint of different programming languages, as you've probably seen. I'm not honestly sure how much weight I would put behind some of those, but
Yeah, they're micro benchmarks. So
right. Yes. Yeah.
Although one interesting thing with that study that I will call out, because again it's a bit counterintuitive, because normally we sort of have this mental hierarchy where we imagine that the compiled languages are better and the harder languages are better, which we sort of see in that result. So C and C++ and Rust were all extremely efficient. There wasn't much to choose between them. And then we imagine, a language like Go, which is kind of hard and quite compiled, that's going to be better. But actually, Go had a higher carbon footprint than Java. And that was even before looking at something like Quarkus, which halves the carbon footprint of Java. So it does mean that definitely if you are using Java, and overall I think they looked at like maybe 60 languages, and Java was 5th. So Java, even before Quarkus, is really, because it's so fast, because it's It's just been so optimized, and the GC is really optimized, the JIT is really optimized. It means that if you're using Java and you want to keep using Java because you like that programming model, you're in an okay place. You can keep doing that.
Yeah, I found that genuinely surprising, how high it was. I was also kind of amused by how terrible Python turned out to be.
Yeah.
Which was also kind of a bit of a... I mean, you kind of figure it's not going to be great, but it was sort of startling how bad it actually was. And given that, like, obviously we're at a tech conference and everyone is talking about machine learning kind of in the coffee spaces and whatever because of ChatGPT and all of those sorts of things.
Yeah.
It's just kind of interesting to reflect on how much particularly data science type work is done with things like Python and R, I suppose, and those kind of things. And a lot of those languages are quite bad from a carbon point of view, which is kind of interesting, I guess.
Yeah, absolutely. I think for the data science workloads, it's not quite as bleak as it seems from those micro benchmarks, because I think a lot of the heavy lifting is outsourced away from the actual Python runtime.
Yes, yeah.
But still, not all of it is, and so it is worth thinking about.
Yeah, I think the other thing there, of course, is like training a large model is incredibly expensive, but that means that people don't do it that often. There's only really 3 or 4 companies that have the kind of the resources and the money to do that, and then everyone else is building on what they're doing. So it may not be quite, as you say, it's not quite as bleak as we might think it is. Thinking about sort of sustainable software more generally, are there other things that you think as developers we ought to be thinking about when we're thinking about our kind of environmental impact on the world, and sort of thinking about, I don't know, demand shaping or those sort of areas?
Yeah, there's some really interesting and cool and kind of challenging and not yet built technologies in this area, which is always exciting because everybody loves a problem. And there's some really easy no-brainers in this area, which is also good. So the first thing to think about is where your workload is running in general, and if it's in not all regions of the world have the same electricity mix, and some it's very dominated by coal. In others, for example, the Nordics, it's much more focused on renewable energy. Mm-hmm. So in a lot of cases, you can move your workload and slash the carbon footprint for no work at all. And often as well, actually, the hosting costs can be cheaper in an area with clean energy than one with dirty energy. So again, it's kind of, why wouldn't you do that? Sometimes there's latency reasons why not to do it, but if you there's a site called Electricity Maps, and you can look and you can see, and most areas of the world, except for maybe Asia Pacific, where the energy mix overall is a bit more challenging, there's something that has acceptable data residency and acceptable latency that will be on greener energy. So that's just the kind of the no-brainer. But then, as you say, the demand shaping is the next thing. Of a lot of renewable energy tends to be intermittent. Mm-hmm. So I think a lot of us think, okay, I'll run this overnight and that will be greener. But not if your energy is solar.
Right, yes. Yes.
And so then we're starting to see now this kind of carbon-based dispatching, where you can get the real-time information that says, well, the sun isn't shining in Denmark because it's Denmark. However, the wind is blowing in Scotland because it's Scotland. So why don't you run it on the wind energy in Scotland? Whereas tomorrow, actually, the sun will be shining in Sweden, so then you can, move your workload there. And as long as you've written your workload in a modern way where it has that idempotency and where it can be scaled down and up and moved around, then again, you get your disaster recovery kind of for free, because you've proved that you can take your workload and pop it up in various places and it works, which is good. The business will thank you. And you're also lowering your carbon footprint.
So yeah, and the other thing that's sort of related to that, I think, is thinking about, do you need all of your workloads to be sort of real time and that kind of thing? Going back to, we used to do a lot of stuff in batch when I started in the industry, and we kind of went away from that because computers got quick and fast and cheap. But maybe, you can batch something and, as you say, run it somewhere else when the sun is shining or the wind is blowing or whatever renewable source you've got, but you don't need that kind of real-time thing, which is maybe something to factor in.
Yeah, definitely.
The other thing that I was sort of interested about, so you spent a lot of your career, one way or another, working with Java. So what is it about Java itself that you like? Why are you sort of drawn to it as a language and an infrastructure?
Languages is such an interesting question because I've worked with Java for so long, I speak Java. And I was quite surprised a while ago when I was working with people who were coming from JavaScript and I was watching them trying to program in Java. I was pair programming with them and they were stumbling and I was thinking, why is this not obvious to you? And so similarly, when I go to some other languages, sometimes I find it really hard, and the people who are more accustomed to that language say it's easy. So part of, if I'm honest, part of the appeal of Java for me is that kind of incumbency and inertia. But on the other hand, when you look at the Java ecosystem as a whole, there's so much to love about the language. I think it has a really nice combination of stability. So I was watching someone a while ago, they did a demo and they took code that was from 2008 and they ran it. And it not only it wasn't Hello World, it was actually using their product and using the library, and it still worked. And there's not many ecosystems where you could take code that ancient, that was actually written before some Java programmers were born, realistically,
right,
and it just worked. And yet at the same time, the Java ecosystem is absolutely not stagnant. So you have the emphasis on backwards compatibility, but also the emphasis on forward progression. So if you look at GraalVM, for example, that's just such a huge change, and it's so exciting. And then if you look at something, and that's sort of in the JVM, or it now is, but then if you look at something like Quarkus and the sort of, the ecosystem that's built up around Java as well, you get all of these incredibly exciting, cool things. And I think that's exactly what you want, isn't it? Of type safety to save you from yourself, and stability to save you from the past or the future, depending which way you're trying to run it, and yet forward progression so that you still get the new shinies and it still just keeps improving, and you still get that little endorphin rush as well. If you go to a new Java version, you're like, oh, this is cool.
Yeah. I think I would add as well, Java has a particular quality about the way people write Java code. Like everyone's Java code looks very similar, which means you can pick someone else's code up and follow it and make sense of it in a way that is not, I think, true of all languages. I'm not quite sure what it is about. I mean, some of that is probably when people talk about sort of verbosity in the language and whatever, it's sort of slightly related to that. I think that there isn't a lot of sort of magical, the sort of meta template programming type stuff from C++ or Beast or any of those things where you're like, I've got no idea what this does anymore. Java's like a very easy language to follow.
Yeah. And there's not the technical capability and there's not the culture of saying, I could write this in 10 lines so it's understandable, or I could write it in 6 characters to show that I'm a rock star.
Yes.
And, you just don't get that in Java.
Yeah, I think that's interesting too. So in terms of what you're working on at the moment and what you're doing at the moment, what's kind of exciting to you that you're doing? What's sort of motivating you at the moment?
So a lot of what I'm looking at now is that sustainability and looking at Quarkus and sustainability and looking at sustainability in more general. And another thing that I'm looking at again is going back to the microservices and how can we deploy microservices with confidence, because if we can't deploy microservices with confidence, what is the even point of microservices? And I think contract testing is a huge part of that, and contract testing isn't very widely used, and so I'm trying to figure out, well, why isn't it widely used? What are the barriers to it? Which is partly just talking about it, but I think it's also more fundamental of why aren't we all contract testing? What do we have to change?
Great. Well, thank you so much. It's been lovely to chat to you.
Yeah, my pleasure. Thank you.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.